All right, this is Algebra 2, Lesson 33, the major rules of algebra. We have covered these over and over and over again. But you can't say them enough. Because you know what? When you get to pre-calculus, what are we going to forget? The major rules of algebra. When you get to your higher level maths, that is typically what you forget to apply. The first one is addition. What is true in algebra about the addition axiom? They're called axioms. If I have an equation, what does that mean? Therese?
Something is equal to something else.
Something is equal to something else. What does the addition axiom tell us? Yes, Evie?
You can add the same thing to both sides of the equation.
Exactly. I can add any value to both sides of the equal sign and it does not change the equality. In the same manner, I can subtract any value, the same value, from both sides and not change the equality. All right, what is multiplication and division in an equation? What do you think that axiom says? Or that rule of algebra? Multiplication and division. So addition and subtraction says add or subtract the same value from both sides of the equal sign. What does multiplication and division say? Therese?
You can multiply both sides by the same number and it will change the solution. And you can divide both sides by the same number and it will change the solution, except 0.
Correct. And with multiplication and division, I have to multiply or divide every term on both sides of the equal sign. With addition and subtraction, I don't add or subtract to every term. I add once on both sides of the equal sign, the same value. With multiplication, I have to multiply every term in order not to change that equality, or divide every term by the same value. Do you see the difference between those two? All right. The denominator rule. What does the denominator-numerator rule say? Look at it, number 3. Yes.
The denominator and numerator of an expression can be multiplied or divided by the same quantity without changing the value of the expression.
Okay, what does that mean? That's exactly right. What does that mean?
You can multiply or divide by what is effectively 1.
That's right. I'm effectively multiplying by a fraction that is equivalent to 1. XY over XY. That's what that rule says. Right? That's how we make a common denominator. So you multiply both the numerator and the denominator by the same value, which is effectively multiplying by 1. I don't have to multiply every term by that same value. I can multiply one term by 100 over 100 without changing the value of the equation. Make sense? If there is no equal sign, how do we handle denominators? No equal sign. How do we handle denominators? Okay, someone other than Therese. Yes, Hannah.
have to move common denominator.
Common denominator. And that's when we use that previous rule we just talked about. If there is an equal sign, what do we do? Come on, guys. I just gave a pre-calculus test. Someone did not follow this rule. If we have an equal sign, what do we do, Mackenzie? Eliminate by the multiplication rule, right? We multiply every term by the same value and eliminate the denominator. All right? That's all the rules. The only time we can eliminate a denominator is when? Equal sign. If there's an equal sign, 100% of the time I'm eliminating the denominator. All right, let's not forget those rules. All right, then we come to complex fractions. How is this different from what we've already learned? What we've already learned is a fraction over a fraction. Now we have in the numerator or denominator a fraction plus a fraction over a fraction. There's no equal sign, so we are always going to a common denominator. All right? But wherever there is addition or subtraction of fractions, that's where we're going to begin with a common denominator. So we want to end up where we've been. We want to end up with a fraction over a fraction. All right, so look at 33.1. All right, so I want to begin working in the numerator because that is where fractions are added. Because I have no equal sign, I'm making a common denominator. What would be my common denominator, Michael? In the numerator. Right. XY, that's right. And so all I need to do to this first term is multiply by x over x. So I end up with x squared over y plus 4yx, xy, 4 over yx, same value over a over y. Now I move that sign to the numerator in the numerator, and it's x squared plus 4 over xy over a over y. Now I have a complex fraction like I've had before. Now how do I handle that complex fraction, Nathaniel? I want to simplify it. A numerator over denominator, not fraction over fraction.
You multiply by the reciprocal.
Of the, which reciprocal?
A over y.
Correct. Reciprocal of the denominator over itself. Y over A over y over A. Because, okay, I want everybody to listen to this because this is also a problem that I see oftentimes. You can only eliminate terms that are multiplied. Okay, I'm just going to show you something. I'm making up part of the numbers. Okay, that was a problem on just the last pre-calculus test. You know what some people did? Why can't I not eliminate that lead term? Because they're not all multiplied. Let's lock this in our brains. Yes.
If 7x to the third is multiplied by 5x squared and the same is at the bottom, would that work? Yeah, that would work.
That works. The other does not work. Do you see the difference? Things become more complex, and that's when you forget the rules. Let's not forget the rules. Okay, so I have to distribute this y to both terms in the numerator. So it's x squared y plus 4. Wait, just a minute. Just a minute. Say that. I can eliminate the y, but because they're multiplied. All right, so this y can eliminate that y. The minute after I multiplied, I said, wait a minute, I'm going to have y everywhere. All right, so this is just 1 in the numerator, so it is x squared plus 4 over xa. Good catch. I'm glad y'all are watching and paying attention. All right, the next one is obviously a little more complex. I hate that I have to erase, but I do need to erase. A over x plus y plus m over y all over x over a plus m. All right. Where am I going to begin, Sarah? What do you think? Well, I have something added in the numerator, 2 fractions added. So I want a fraction over a fraction. Okay, I don't want this. I'm going to make a common denominator in the top. Jaden, what am I going to do?
I'm going to multiply x plus y over x plus y to the second term, and then y over y to the first term.
What's going to be my common denominator?
It's going to be x plus y. Y times x.
Correct. Explain to me, I hate to use the word y, but I'm not meaning the letter y. Explain to me the reason for having a common denominator of y times x plus y. Therese.
Because x plus y, well, they're added, so you can't separate that.
That's right. This is a binomial. It can't be x plus y, because what would I multiply this by to get to x plus y? Well, okay.
X plus 1 over x plus y.
If I multiplied it, how could I get in my denominator? What would I multiply it by to get to x plus y? Could I? Is there anything? There's nothing. I can't multiply by x plus 1.
X plus y over y.
But then I'd have to multiply the numerator
Yeah.
by a fraction, and the whole purpose is to get a common denominator and have a single numerator over a single denominator. So I can't, right? So we have to see binomials as a term when they're in the denominator. Do you understand what that means? As one single term. So it's this term times that term. Make sense? When there's an addition sign. So I'm going to multiply this first term by y over y and the second term by x plus y over x plus y. So that my common denominator will be y times x plus y. So I end up with ay over y times x plus y plus mx plus my over y times x plus y all over x times a plus m. Now what do I do, Jake? What's the next step?
We have to put the numerator onto one fraction.
Yeah, yes. All right, so we have a y plus mx plus my over y times x plus y over x over a plus m. Then what, Jake?
Multiply by the reciprocal of the denominator.
Correct. A plus m over x over a plus m over x. My denominator eliminates. I don't see that I can eliminate anything. I could multiply all this out, but I don't think I'm going to be able to eliminate anything. So I'm going to write it ay plus mx plus my times a plus m, and you can do that, x, y, x plus y. You don't have to multiply the numerator out. You can, but not necessary.